Greetings from my recording studio located in beautiful downtown Bent, New Mexico, and welcome to this presentation on linear equations whose solutions are kind of bizarre. Up until this point, every time that we solved a linear equation, we got an answer. I don't know what that was. That was an eraser instead of a pen. We got a solution where x, or whatever the letter was, equals a number. We always got a single solution. This equation is the one that we developed in the previous presentation where we compared the perimeter of a rectangle to the perimeter of a triangle with certain sides. The perimeter was constrained by the sides that we assigned to each of those geometric figures. And once we worked it down to its simplest form, this was the rectangle side, this was the triangle side, we got the rectangular equation down to one x term and one number term. We can't simplify that any further. I mean, that was our goal, to get it down to where we don't have any similar terms. And then we did the same thing for the triangle. We got it down to one letter term and one number term. We can't simplify any further. There are no similar terms. And at that point, we're going to solve this equation for x. And what we're looking for, what we're hoping for when we start off, is that x equals some number. So we have x on one side of the equal sign, the numbers on the other side. That means when we start off here, we have to eliminate x's on one side of the equal sign. And the hint has always been to get rid of the smaller value x term. The term that has the smallest number, the one that lies furthest to the left on the number line. In this case, 7 lies to the left of 10. We would zero him out. That would be 6x, add a negative 7x. Go ahead and bring down the 18. And since I added a negative 7x on this side, I'll do the same thing on the opposite side. It's going to be 10x, add a negative 7x, add 6. We know that these 7x's zero out. That's called the additive inverse. That's why we do that. Now we have 18. Over here on the left-hand side, we have 10x plus a negative 7x. We know that this is really just a subtraction, adding the opposite. So 10x subtract 7x will give us 3x. Bring down the add 6. All of my x's are in one place now. That's the last thing I'm going to deal with, is him. I need to zero out this positive 6. We're going to add a negative 6. Add a negative 6. And then we have 3x equals 12. This is a multiplication. To undo the multiplication, we multiply by the reciprocal of the coefficient on the x term. The reciprocal of 3 over 1 is 1 over 3, and we multiply both sides of that equation. This becomes a 1. That's why we do that, because we want 1x. And then 12 divided by 3, I'll go ahead and factor that 12. So you can see that the 3's cancel out. So we're left with 1x equals 4. All right. So at some point I may ask you, how many solutions are there to this equation? And you can go through this entire process like this, but if you know some secrets, you can save yourself a lot of time and save yourself a lot of opportunity to make a mistake in here someplace by recognizing, and here's the hint, if there's going to be one solution, the coefficient on the x terms will be different. Let me say that one more time. This coefficient and this coefficient will be different. If they are different, you get one solution. So if I gave you an equation like 5x plus 6 equals 3x minus 9, and I ask you simply, how many solutions are there? You look at this 3 and this 5, they're not the same. You would have one solution. It's like magic. We'll show you the magic in a little bit more detail as we get into graphing equations. Becomes very, very obvious why once we start graphing these things. That's beyond us right now, but that's your secret. If the coefficients are different on the x term, once you get everything down simplified as much as you can like this, where you have x's on both sides, you don't have any similar terms, you compare the coefficients on the x terms. If they're different, you have one solution. All right. Let's move on. If we had compared the perimeter of the rectangle to the perimeter of the triangle, and we got this equation, we'd go ahead and start working it exactly the same way. Now look, this equation on the left-hand side is exactly the same as the equation on the right-hand side. I'm going to show you two different ways of approaching this. What I'm wanting to know is how many solutions are there. So, working on the left-hand side of this page, I'll notice that this 8 and this -6 are even numbers. And I can divide an even number by this 2 right here. So I can do it this way. I can just go ahead and divide. I can multiply each of these terms by 1/2. And 1/2 of 8t will give me 4t. And then -6 divided by 2 will give me -3, and then that equals 4t subtract 5. Each side of this equation is in its simplest form. There are no similar terms. At this point, I'd like you to notice that the coefficient on that t and the coefficient on this t are the same. If that is the case, then we don't have one solution. But let's go ahead and work this like we normally would. You know, what we're expecting is that we're going to have t equal something. We look up here and we have t's on both sides of the equal sign. So we're going to have to eliminate some t's on one side. Doesn't make any difference. I'll just add a -4t to both sides. These four t's zero out, these four t's zero out, and we have negative 3 equals negative 5. This is not a true statement. If I get something like this and it's not a true statement, that means there are no solutions to this. There is no value of x that will make this equation true. And you can just go ahead and put in a couple of numbers. Put in any number for t. Let's try 0. So we have 4 times 0, negative 3, equals 4 times 0, negative 5. This cancels out, this cancels out. This leaves us an untrue statement. And that would be the case for any value of t that we put in there. All right, we knew early on that there wasn't going to be a single solution because this coefficient and this coefficient were the same. So we've done that. Now let's come over here to the right-hand side of the page, and I'll show you another way to do this problem at least halfway through. I don't like denominators. And I think somewhere in an earlier presentation I said we can multiply this entire equation by that denominator, by the reciprocal of that 1/2. And this become 2 over 2 times 8t subtract 6 equals 2 times 4t minus 2 times 5. That cancels out. Now we have 8t subtract 6 equals 8t subtract 10. And then we would just take it just like we did over here by adding a negative 8t to both sides. And once we did that, we would get negative 6 equals negative 10. That's not a true statement. All I wanted to show here was instead of dividing by this 1/2 over here on this side, that we multiplied the entire equation by that denominator to get rid of that denominator. It's up to you how you do it, but if you recognize that you can divide inside that parentheses by that 2, go ahead and do that. Saves you a little bit of time, gives you smaller numbers at the end. Doesn't make any difference. You can do it either way. It's up to you. All right, so we got an untrue statement. That means there are no solutions to this equation. There are no letters, no numbers that you can put into that equation and get a true statement. Next situation. Whenever we compared the perimeters, we got something that looks like this. Oh, this is ugly. We have denominators every place. You know I hate denominators. I'm going to go ahead and get rid of that 5 as quickly as I can. I'm going to multiply the entire equation by 5. That becomes 5 over 5 times 2x plus 7 equals 2 times 5 over 5x plus 7/2. Those 5's cancel out. That's great. I got rid of that denominator. Now I have 2x plus 7 equals, these 5's cancel out. That leaves me 2 times x plus 7/2. The left-hand side of this equation is okay. It's in its simplest terms. There are no parentheses, no similar terms. I'll just go ahead and bring them down. We have parentheses here. I'm going to distribute this. That will give me 2x plus 2 times 7 over 2. Those 2's cancel out. That leaves me now with 2x plus 7 equals 2x plus 7. Recognize immediately that these coefficients are the same. So I'm not going to get a single solution. But if I go ahead and work this thinking that I'm going to get x equals something, I'll go ahead and get rid of this x on this side, add a negative 2x, add 7, same thing over here, 2x, add a negative 2x, 7. That zeroes out, that's the additive inverse, and at the end of the day, I have 7 equals 7. That is a true statement. And what that means to you is that you have an infinite number of solutions to this. Any number that you put into this equation, let's go ahead and look at it. So we have 2x add 7 equals 2x add 7. I know that there's not a single solution because these two coefficients are the same. But in this case, when I solve this, I get 7 equals 7. True statement, that's saying no matter what number I put in for x, I get a true statement. So I have an infinite number of solutions. Infinite number, that's a big number, infinite. More than 10. Let's just put any number that we want in for x. Let's do 0. If I put in 0, that's going to be 2 times 0 plus 7 equals 2 times 0, add 7. That's a 0, that's a 0. Let's put in a 5. 2 times 5. Ooh, that's an ugly 5. I have trouble with 5s for some reason. Let's slow it down. 5, 2 times 5, add 7 equals 2 times 5, add 7. 2 times 5 is 10. Nope. I want 10. Nope. 10 plus 7, 17 equals 17. Now we could spend the next 5 hours putting numbers in for x to try to convince ourselves that that's true, that any number works, but it does. Just accept that. We know 2x add 7 equals 2x add 7. This number equals this number. This number always equals this number. They are the same term by term across, right? This equation here is exactly the same as this equation here. Once we've simplified everything, that means there's an infinite number of solutions. Whatever number I put in here goes in here, and we get the same true answer every time. Infinite number of solutions in this case. There was here, we got something that looked like this. That's not a true statement. That means there are no solutions. And in this case, we just got x equals 4. That means there is one solution. All right, that pretty much wraps that up. You know what the secrets are now, right? Try to remember those. So that wraps it up. And there's only one thing for us left to say. And that's all, folks. Double exclamation. Pretty curly thing down here. Cross it twice. Guys, thanks for watching. Thanks for learning. Be safe above all. Con cuidado.